Hello, hello. Hi. Would you like to talk to us all, Tim? Okay. Hello. Thank you for joining us for this breakout session about open practices for education and training in open source. We have first up Tim Dennis, who leads the OSPO at UCLA and is the chair of our education working group. And he's going to be telling us about what all the education working group has been getting up to. Would you like to?
We are going to have more panelists, right? Okay. Can I get to my slides? Oh, they're part of this? Oh, it's the PowerPoint. That one?
That one, Dennis. One there.
Get my note.
Yeah.
Oh, there it is. Nice. All right. So welcome everybody. I'm Tim Dennis, and thanks for coming. This is the Open Education Group, part of the UC Open Summit for 2026. So yeah, and we'll have a bunch of panelists up here following me. As part of the OSPO, one of the things we wrote into the Sloan grant when we developed the network across 6 campuses was a education component. And we basically were saying, hey, there's a lot of educational material out there, but it's not really organized in a way that's really useful for our community that we're building. So we proposed to develop an inventory, and part of this was selfish on my part because I didn't know what an OSPO was, right? I didn't, it was kind of, so like I'm just typical librarian. Let me gather a bunch of resources, organize them into some inventory, and make it, have sufficient metadata and make it easily discoverable so people can use. So that's kind of what we did. And we found out, for this community that in OSPOs, there's many different roles, especially in academia. You could have a researcher who is working in some scientific group that needs fair compliance, and that's like a open data compliance and reproducibility for their lab. Or it could be somebody who's just getting started, wants to contribute to a project, needs Git basics. They don't know anything about Git. How do I get started with Git? And contribution and get confused about pull requests and how you actually contribute to an open source project. We also, people that need clarity on how you would commercialize a product, the tech transfer kind of area, like what licensings we need to apply. We know there's a sundry of licenses in the open source world. There's a sundry of licenses that UC recommends across its various institutions. So there's people that could get lost with that. And then there's also people that might be working with tools that require access to sensitive data and need more secure requirements. So all these, we know these are different people that are involved in this whole an OSPO itself, and they're coming to an OSPO like ours that we're building, and we want to be able to meet their needs and help them educate themselves, but also in a concept of train the trainer, because I'm part of like this larger education group called the Carpentries, where we really teach people how to teach others, right? That we assume that we're have good pedagogy, we care about the actual audience that comes to us. So we won't have all that defined when we provide educational materials. So this is kind of, I've jumped ahead, but this was done through a system-wide group. There are many people in the room or also at this group that they're part of the education committee. Ryan, Rita Suji at UCSD, Carla Padilla, who's downstairs, I think right now at UCSD, David Miner, also at UCSD. Laura has been a steadfast member of the group. And what that we did is we gathered all the lessons from various sources. It could be carpentries, it could be Turing Way, it could be various sources of these lessons. They have some good RSE lessons on research software engineering, and we created an inventory. And then we mapped that curriculum using a schema called bioschemas from Europe that has really specific metadata about how to describe lessons in training materials. Then we turned it over to, we had a designer. We're fortunate. Reed had a designer who worked for him, and she's a student, Lauren Reyes, who made some really pretty design mocks in Figma. And I had two students at UCLA that converted into an Astro site. So, and did some engineering on creating it into a CMS, did some data pipelining and made sure things are pretty efficient. The end result of that, which you can see, if there is going to be a live website that we'll have a link to, is a curated, navigable experience, a learning experience where people, based on the role, you can filter down to get lessons that are for a contributor or for an end user, or the lessons that are available for a maintainer or a community manager. And then also we marked it up whether there's a beginner lesson, a intermediate, or an advanced. And we also did a lot of, as mentioned before, we used a defined schema so that all this stuff is machine readable and it'll be highly discoverable on the web. And of course, they're all open source materials. So the big other tasks of our committee, we came across like, okay, how will people approach this? Like, what are these subcategories? Like, oh, I'm just getting started with open source. What I need to know. I mean, open source is it's pretty daunting, you know. I mean, people here, we had conversations at lunch. You get a bunch of acronyms in like 10 minutes, jumping into an OSPO community. That was like one of my first things. I'm going to write acronyms for everything I'm hearing so I can figure out what's going on, because it's the nature of technology, nature of the legal world, nature of all the confluence of things that are in OSPO and open source. We also wanted to support a path where anybody who wants to contribute to a project would have a set of lessons that people can work through. And we're also really trying to interconnect these lessons so we can build a curriculum off of it. And maintaining and sustaining software, the inclusivity of building communities, which is a really important component to open source communities. Like, how do you engage with people online that you might not know, that might be somewhere else physically? How do you actually support communities in an open source world? It's really a distinguishing part of how you really engage in open source. And licensing is a continual thing that keeps coming up, partly because there's so many different licenses for open source, and each UC seems to prefer a different variant, and that is also changed by court cases. So, and then, you know, so all this stuff is just a wrinkle. If you found at UC, if you're from UC, they have like a web page with a PDF of a monster matrix of all the different licenses. So this is a constant confusion for people coming into the community. And part of that is like the conceptual understanding of licensing. And the other one is the actual, like which one to apply in the context you're in. And then strategic practices and career development. That was one where, okay, how do you be a more efficacious contributor, or say you're a researcher, or say you're like a grad student that ends up like writing software, you know, maybe it becomes Jupyter, you know. I mean, literally this is a track that many people have taken in the UC. And then how do you become a better professional in that context? Have good practices on publishing your software, getting a DOI, and all that kind of stuff. So we did put a lot of effort with our students to kind of eliminate, we were doing a lot of this curating in a Google spreadsheet that, you kind of lose, that becomes really hard to manage cross strips between that and GitHub. So we put some effort into defining some, to getting that all into GitHub, and to have a sufficient script process where we could keep things up to date. We adopted all the standards we could, and we did as much automation as we could. And we had pretty good coverage on the metadata that we currently have in our site. What we found is there's lots of material for version control and Git basics. There's copious amounts of Python, R, data science workflows, packaging kind of lessons. There's some general open source contribution guides out there that are really good. And there's one or two basic open source license overviews, which aren't specific enough for at the institution level. And the real gaps that we found, and that we went through a gap analysis, is that institutional security policies, vetting tools for those P3, protection level 3 and 4 sensitive environments, and then basic understanding and applying licensing is not there at the specificity that we need in the UC communities. And navigating tech transfer, because I know our tech transfer, but then how we interoperate better, how the OSPO it's a fluid transition between those things is kind of a missing piece. And the one I think Laura, you did this, what the F is open source, just the basic, you're 3 steps back. You don't even know what this thing is. That literally was my experience. I was like, who are these people? So that's those are the gaps that we're going to try to address. And we'll do that we identified them. Part of the grant paid for a service with the carpentries called Collaborative Lesson Development Training. So we're going to have cohorts of 4. And we do have a 4 cohort for developing the licensing lesson. And we have somebody who really knows licensing on that team. And we're going to develop in a modular way something that's appropriate for UCs. And we'll definitely test it with our tech transfer people to make sure it's solid. But that, the carpentries guides us through writing that lesson in a backward design way where we're doing it pedagogically sound. And we think it'll be solid, and we'll add it to our repo. We just started that, and we're trying to schedule some dates, which is always kind of challenging. And then we'll go through a process of publishing those lessons, piloting them so they're well geared, tested, and then releasing them, and hopefully we'll encourage people to teach them. One thing that we try to plug in along the way is recognize that we have active communities already through the UC. So the UC carpentries, which I'm a co-chair of. I mean, I'm fudging a bit. There are 60 people in a roster, but usually 20 show up at monthly meetings. So the carpentry teaches, coding and data basics. It's a very active community through the UC. We get 500 people a year through the workshops, through all the campuses. And so in my role as a chair, I said, hey, let's join forces. So Laura's going to be coming to our meetings, and we're going to basically cross program and teach our lessons that are OSPO and open source related in this carpentry environment. And that there's a larger carpentries partnership that we can engage with that is similar thing. It's a nonprofit global teaching community. So there's a lot of instructors who are engaged in a similar thing that hopefully we can, catalyze to be able to teach these open source practices. And so, we really feel like this is train the trainer kind of model. This is what it's about. We're learning as we're doing and learning as we write these things. And hopefully more people that are on each campus will learn these concepts and these practices that they can share, and we can all grow as open source kind of practitioners. This one is, I realized I put the library in there. I don't know why I put the library in there. I think that's because I'm from the library, but it's also heavy because the notebook LM did that slide. So that, yes. But no, it picked it up for me, a library, but I think it actually still holds. I still remember Fernando Perez giving a talk when he said the library should be, it's like, we should treat it like the library. It's like Switzerland. You know, he had a slide, and I remember that. Like, yeah, because they wanted to put bids in the library, right? And they did. And it's like, oh yeah, it's Switzerland. It's neutral. So I think that holds for this OSPO metaphor too. This is it's going to be interdisciplinary hub. It's a neutral. We can pull in these other groups. The CKG groups is a library group of librarians, the Common Knowledge Group. Across, they have one on data, one on GIS, one on all kinds of topics. And there is a proposal to try to better integrate OSPOs and the interconnectivity between these already existent organic groups. Love Data Week. Oh, 1 minute. Love Data Week. Laura and a group we taught making research software citable and discoverable, which was kind of a pilot at the last Love Data Week. And the UC Carpenters already mentioned, we'll engage in cross-programming with them. So we'll offer courses through the next, or workshops through the next year as the OSPO grows. In the CK group, there could be an OSPO for that. So we're trying to build out community here that will interconnect what the OSPO does with what already exists in the landscape of the UCs. And I think I'm almost done. And the next steps, we have ideas for like you build this inventory, people like these things. We want something where people can say, I want to build an inventory of using these components and download it. Having some audience feedback loops, and then track better. Because I really like to track when we're teaching these things, people get credit for it. And that's it. There's a QR code. Thank you very much. All right.
All right. Thank you, Tim. And after all of the panelists, or not panelists, after each breakout talk, then at the end of the fourth one, we'll have a facilitated discussion. So if you have any questions for Tim, fear not. There will be an opportunity to ask them. Okay, and where are we here?
Nice.
There we go. I think. Yes, excellent. Okay. And so next up, we have Shane Knapp and Eric Van Dusen from UC Berkeley. Shane is a staff computing engineer at Berkeley and the technical lead for Cal iCore, which brings cloud-hosted JupyterHub environments to colleges across California. Eric Van Dusen has spent the last 8 years helping build Berkeley's data science undergrad major. And together, they're going to tell us today about how they've turned JupyterHub developments into an open source ecosystem that serves thousands of students.
Hey everybody, I'm Shane. This is Eric. We're really glad to be here today. I'm a staff computing engineer for UC Berkeley. I've been here for probably 13 years. I'm the technical lead, project manager for Cal iCore, and I'm also a JupyterHub contributor. Eric is a data science instructor, educator, does a lot of outreach, kind of our biz dev evangelist. So JupyterHub is an authenticated gateway to notebooks, and notebooks are a very small compartmentalized operating system that students can access. They can't see each other's notebooks. Everything just kind of works. Course materials are provided by the instructors. They click a link and it's automatically pulled down into the notebook, and it just opens up into their first lesson of the day. It's kind of amazing. This keeps us needing, to install Python packages or set up RStudio on every student's laptop. And every student has the same amount of compute, same amount of storage, same amount of basically everything. It really levels the playing field for everyone. And, we're not just doing Python and R. We also can support Java and C++. We have VS Code that works really well. Some instructors are using that. And then we also have some instructors like at Sacramento State that are actually teaching people bash skills. So like how to use man pages, what is awk, what is sed. Really, really powerful little Unix command line tools that they probably would have never heard of or used until they encountered this platform. And how do we deliver this to students around, right now we have about 1,500 or more students per semester at, I'm going to say 18 to 20 different institutions around the state. It's all CI/CD, continuous integration, continuous deployment. Everything's in GitHub. We want to make a deployment change to our JupyterHub that goes through CI/CD for testing, and then we get to deploy it. We use lots of community, open source tools to do this. Kubernetes, Helm, Docker. Well, Docker's not really open source, but you get the gist. And then we want to make, an instructor wants to change a notebook and add packages to the system image. We can actually test that system image against the notebook to make sure that all the Python imports work or the proper R libraries are there. The containerization is probably the most important bit of these JupyterHub deployments, right? It's a small Docker container that runs in the cloud. And to use that, we use an open source tool from the Jupyter community called Repo to Docker. And that literally takes a GitHub repo and builds a Docker image that is then deployed to thousands and thousands of students across the state with the click of a button. Cost monitoring, sustainable cloud operations. It's a pretty low stress cloud environment, which we're running on the back end. The only thing we really worry about are like, weird spikes in costs. So we have automated alerts set up for that. And then, infrastructure as code. That's like it's been a new hotness for a while now. Our infrastructure is actually pretty static, so it's kind of been on the back burner for a while, but it is on my list of things to do. So what I'm talking about here is the right side, the invisible admin. And as a 6'2" person, I am far from invisible, but most people don't know that. So everything from the right over is what I do. So authentication, we use CI logon. I'll go into that a little bit. Configuration packages for the user images. We use Prometheus and Grafana for, our monitoring and our alerting. I did not put PagerDuty on there, which is another free resource that then will actually page me if something goes down. I've done contributions to the Kubernetes kube spawner, repo to Docker. I've done a little bit of work on, and it's like, this is all invisible to the user, to the instructor, to the student. I could talk an hour and a half about how this all works, and I have, but I won't. But it's just really great that no one knows this exists and it just works. The other thing we like to do is contribute to the upstream projects. Cal ICOR, the project that I'm working with right now, is pretty small potatoes compared to the UC Berkeley JupyterHub deployments. So UC Berkeley sees 15,000 users a semester, all doing data science reproducibly in a containerized environment, and everything just works. So UC Berkeley would see things that happen that no other university, no other institution would see. UC Berkeley has one of the biggest deployments of JupyterHub in the entire world. So thousands of students we're getting feedback from instructors, students, our own staff. And any work that we can do to help contribute upstream will reduce things like technical debt and just make the project bigger and better than it was before. And it takes a village. And then expanding beyond Berkeley, we're trying to do this for the state of California. Not every institution can afford a DevOps team. And we have this whole deployment system down through CI/CD, through GitHub, through Kubernetes, that we can spin up a new JupyterHub instance in minutes for a new partnered institution. And then, it's just a unified ecosystem. If a student goes from one Cal to another Cal, they're already familiar with how everything works. And you can start on day one. So I'm going to hand this off to Eric, who's going to talk about the non-invisible side.
So some of the question is like, we have this awesome JupyterHub deployment at UC Berkeley. How do we spread this out? How do we make it so that a community college student taking an intro data science class can have the same platform, same way to compute that the UC Berkeley students have? Like, how do we level education? So part of it is our 2I2C partnership. 2I2C is like a nonprofit with a big mission around making these open source deployments available, around the country or around the world. Many of the people that helped to develop the UC Berkeley tech stack are now at 2I2C, and we have had years deploying this out to community colleges in partnership with them. And that's more like on the socio side, like how is the people, how is creating communities, how is sharing tooling, something that enables scaling. That's very related to open source. I guess the other would be NRP. This is coming out of San Diego Supercomputer Center. This is a little bit more on the hardware side, right? Like they have interconnected hardware around the state of California that like can become a public cloud. But again, this is using open source tech stack to make it sort of widely available. And so we're collaborating with both sides here. How can we scale out this educational use case? So one of the questions is like, is our curriculum in the way it's designed and deployed some open source engineering, right? So there's a number of ways that the curriculum's built on an open source stack, but there's a number of ways also that we deploy it, that we scale it, that when the community college comes to me and they say, hey, I want to teach Data 8.2, that we give it to them. That's like using these open source software packages. One thing that's recent, and I'll get to at the end, is like how are we going to teach AI? And are we going to be able to use this open source approach when we shift from like just teaching the data science tech stack to some AI tech stack? So two of the things I want to talk about of like who's the teacher here, right? So some of mine is like doing outreach to the teacher, showing the teacher how there's this open source approach to curriculum. In some cases, it's a community college math teacher. They don't know GitHub. They don't know software engineering. They don't know any of this. And I have to give them little elements of what it means to take a curriculum off of GitHub and learn little bits of this flow, the minimum they need to deploy their class. And then in the UC Berkeley case, we'll have some power user who like has some opinions and some ideas and some package that they're stuck with. They're like, can you make this package run on JupyterHub? So we have both kinds of users, right? And we need our like the open part of our tech stack to work with both types of users. All right, and Jared's not here, but here's my idea of like a lot of Berkeley data science education is climbing up a scientific Python ladder. Like if I get you at first in Data 8 and I'm like, Python, NumPy, Jupyter, right? That's where I started in Data 8. These are all things that you can keep going. You can keep climbing in. I like Data 8. I want to keep doing this. I'll go to Data 100. I'll learn Pandas. I'll learn scikit-learn, right? I get to the like upper division classes. This is like, the top of the tech stack for, computer science or data science is like getting to learn PyTorch or TensorFlow by the time I'm graduating from UC Berkeley. And then my stuff that I'm trying to work on now is like the Hugging Face Olama. Can I also teach this in Jupyter as well? So there's some scaffolding, and there's some design, right? So JupyterHub as deployed as a public project, everything's in public repos. So we don't put any proprietary software anywhere on it. So proprietary software is not touching anything here, right? So by design, it's all open. And then, I feel strong saying like, hey, you student, I have kids in high school, kids in college, right? And we were like, start with Python up at the beginning, and that will give you the ability to go anywhere in science and use these tools wherever you end up. And I'm also saying this now on this like, what is AI education thing? Start with Python and Data 8 because the tech stack over in AI is almost always like a Python harness, right? It's little ways to plug into things that are Python harnesses. How you're going to interact with TensorFlow and PyTorch are basically like similar like Python arguments that you could have learned already. All right, so Jupyter education at scale, it's a lot. It's these classes as a framework, and these are also, think about classes that we teach at UC Berkeley with thousands of people, but we also share, right? So Data 8 as a class, 1,500 students at UC Berkeley. It's got something like 40 or 50 notebooks. It's got a textbook that's stitched out of notebooks. And it's all completely open. Everything Data 8's in a repo, right? And Silas, who's here, I also wanted to say as part of these slides, there's a lot of people that are working together in community, contributing and learning these practices. And so, we are maintaining in the course staff. This is a really interesting thing. Like Rebecca's here, who's from Data 100. Like Rebecca comes in, becomes a TA on Data 100, learns to manage this open source project of Data 100, and then she's going to graduate and she'll be like teaching the next. This is also undergrad students, right, who are going to manage this open source software engineering class that's going to teach a class of 1,000 people, right? There's lots that you could say that only with open source would it be possible to run such a complicated project and transfer it semester to semester from student to student, right? This is me. So I came in, I didn't know what was going on. I learned this tech stack 5 or 6, 7 years ago. Chris Holdgraf, he was here, but he walked out. Like I learned a lot from Chris Holdgraf. And so I made a class that follows this pattern, that follows this tech stack. I have the textbook that's stitched from notebooks. I have like the weekly assignments. So everything from my class that's ever been taught is in a public GitHub repo. I don't know if people around the world are using my class. I know that people around the world are using Data 8, but it's also kind of cool. Like if somebody is interested, you're like, everything that I've ever done is out there in the public domain as open source. And this is different in education. I know that this is a room that's convinced about open source, but most faculty members hide their syllabus. They don't even share their syllabus. It's all hidden behind a Canvas wall, right? And so you're like, everything's out there. The calendar's out there, the syllabus out there, every assignment that's ever been written is out there. This is a different approach to education. So here is our graph that Shane already showed. And think about, I just want to say like my role is like teach that person up there. Teach that instructor. Here's what you need to know. Here's how GitHub works. Here's how this funny tool that UV Panda made up with 10 years ago named NB Git Puller works. Like some open source tool that you need to use to deploy your class. Otter Grader, like some fiddly package that's used to grade assignments at scale. Like these are all little pieces, and then me doing my professional development, convening instructors, come to my professional development workshop. I'm teaching them how to use open source packages, right? And the hope is that the student is invisibly just ending up in our studio Jupyter lab, but they're going to have a scaffolded tool set that they can move up in. So really quick to end up, like the instructor, they need to build a class. They need to get course materials, open source course materials. They need to distribute those materials out to students, and they need to be able to build demo notebooks. So me as an instructor, I'll build like a new notebook every couple of days, and I'll need to deploy that out to students in real time. And then they have to have some way that assignments get submitted and graded, right? And then Sean Morris, who's not here, is somebody that we work with who deploys the whole system for the instructor and sets up. So you're at a community college anywhere in California, and that Sean Morris will set up the whole rig so that you can teach your class. And then Shane for like CSUs teaching at a pretty big scale at CSUs as well. So there's some of like how this material gets deployed. All right. Last slide. This is my side quest for Spring 26 is like, what is it like to teach AI? Everybody wants to talk about AI. Every conference you go to, it's like AI. But I was, my meme here is, did anybody get the meme? It's a hugging face inside an Olama, inside a Jupyter. So that's my like design criteria. Can that be taught? So this is my take, is like building notebooks. And then it's been hard. The AI stack is changing so fast that stuff breaks. The data science stack feels like gloriously stable compared to the AI stack. And then how to get students on a GPU. This is like work that's ongoing. That's also a pain in the ass, but we're learning a lot along the way. That was it.
Thank you, Eric and Shane. Okay. All right, so I have a question for each of the talks to start us off, and then I will open it up to the audience questions. For Tim, I was wondering, you mentioned that there were gaps in like curriculum gaps, especially around like licensing and TTO and all of that kind of stuff. But what curriculum gaps surprised you the most when you made the inventory?
Hello. Well, to be honest, it was the licensing one.
It was licensing.
Yeah, because I didn't know what a mess it was.
Uh-huh.
I mean, I didn't know how diverse the requirements and the options and all the things around open source licensing, and then the compliance and from all the different at the UC level, both at the office of the president and then at each campus had different wrinkles and different licensings that they've created. So it was a bit dizzying. I was surprised that was, I mean, in retrospect, we shouldn't have been surprised. Oh no, what did you think? You're in the team. Which one?
Well, I didn't prepare to answer this question. I don't know. So it's not exactly a gap, but actually well, sort of, it's the maintainer mentoring contributor gap, actually. The how to do what Emily does gap.
Yeah.
I would say that was the most surprising to me, because it seems to me like, obviously you need these kinds of resources, and yet. Yeah.
Cool. I asked her that because she was on the committee. Right.
And I have a question for Shane or Eric or both. What does it take for another institution to adopt the JupyterHub model? And is it mostly technical or mostly political?
Mostly political.
Mostly political.
Yeah, the technical bit we have handled.
Yeah.
I think finding a Shane at your campus.
Oh, BYO Shane. That does sound like a tricky one.
Yeah, like how do I say this? Hasn't really been mentioned at this workshop, but the alternative to open source software is pay software, right? And there's lots of people in IT that are like all about the contract and all about like get the contract with the big IT and don't roll your own, like buy the service, software as a service. I mean, this is the world we live in, right? Like UC Berkeley does not run its own email servers. Google does, right? So to that note, you need somebody, a Shane type person who's like willing to dive in with this huge complicated project and be like excited about the open source nature of it. Right. So there's like a social cultural aspect to like somebody in campus IT who's excited about an awesome, cool open source project. And fortunately, there's lots of people like that. And they work in research computing sometimes. But the other thing that I will say is a little bit of the struggle is there's a world of people that work in research computing that don't see their mission to serve the classroom. Right. And so like, in Shane's background, he was over there, working in College of Engineering for like these big profs doing like these giant, big infrastructure plays.
Like Apache Spark, which I've heard mentioned a million times. I was a build engineer for 7 years.
But he wasn't like stand in front of supporting classroom infrastructure, right? And so that's also a funny thing. Like, Balaji's on a team that is part of the people that support classroom instruction, and they are a different world. They don't go to the same meetings. They don't even really overlap with what's like research IT support HPCs kind of people, right? And then suppose you're at a small college that's not like a UC Berkeley, and then maybe your team is small and you don't have the capacity to take this on. In that case, we have some giant grant-funded projects that we will do it for you.
And to Emily, what's the biggest difference between students who come through a formal course versus a mentorship program?
Like in like at the end?
Yeah.
I think in my experience, like when I've gotten to teach, I've still taught with fairly small classes. I was teaching at a liberal arts college, so I had maybe like 20, 25 students. When I'm mentoring, though, I usually have an even smaller group of students. So I think one key distinction is that in a mentorship context, I get to spend more time on the personal relationship with students and connecting also students with other personal relationships in open source. So I think that the students that I've worked with in a mentorship capacity tend to come out with like more holistic understanding of what is open source, what are the opportunities afterwards, and especially with more concrete like foothold with the community, perhaps. So I try to scaffold all that stuff in the classroom too. But I think that it's also different for students when they're juggling during the school year, like seeing this work as an assignment versus seeing it as a more of like an internship opportunity, maybe.
Right.
So yeah, probably just depth of relationships. And I see more students in a mentorship capacity. I see more of those students also go on as continuing contributors, actually. So that's probably the key answer right there. Yeah.
Higher retention rate. Yeah, that makes sense. And to Ioannis and Allison, how do you think about the tension between using Gen AI to help educators versus the concern that it might undermine the learning process?
Yeah, so this is a very interesting tension, and it's something we explored, for example, through the creation of PromptHive, where we wanted to empower subject matter experts instead of replacing them when we created that tool. And it comes basically as to how you go about implementing generative AI. So for example, for PromptHive, the focus remained giving subject matter experts the tool to create content as they see fit, rather to just create a process that streamlines the content pipeline. And this created basically an environment where the subject matter experts can collaborate with Gen AI and they choose how to use it. And at the end of the day, this process requires human input. It's collaborative between our team and the teaching staff that gives us feedback that we iterate upon and so forth. And this mentality of the content pipeline can also be applied to the tensions that arise with using generative AI in the classroom. Whether we like it or not, students are beginning to adopt these systems. So it's important that as educators, we are there to provide guidance and provide responsible use of these systems and implementing them in meaningful ways in our classroom that empower students rather than have students offload their cognitive effort onto these chatbots.
Yeah, I think as a previous member of the content team and using PromptHive before I joined Dev, it's pretty clear that even though it streamlined my workflow, I still very much had to do the work of thinking about how the student interacted with the content, the learning objectives of that lesson, and how to prompt. As I said, there's the prompt library, so how to specify the prompt for the given content and the hints and explanations. I think in terms of the hints that are generated, they're still very much static hints. Like the students still very much have to learn the content, go through the workings, and the chatbot is still currently not available to students since we haven't like thoroughly tested it. But the prompt or the prompt behind what the chatbot gives the student is pretty firm in the fact that you should never give the student the answer and work it through a way a student would work with a teacher.
Thank you. And so now I'd like to open it up to questions to the entire room. Who would like to go first? Oh, Renee has a question. Awesome. Yes, please. We do need to use the microphones so that the questions are preserved for the recording.
And this is for all y'all. If you got to design a single on-ramp that would reliably turn students into open source, long-term open source contributors, like what are two things that absolutely have to happen?
So one thing would be being comfortable with the tools and workflows of open source engineering, understanding what it means to do an issue, a pull request, code reviews, and just kind of get that technical barrier out of the way, because it's not just technical, it's also social. How you interact with upstream developers that you may only speak with on a mailing list or issues itself. So that's one thing I can think of.
Yeah, I think for us, like thinking about as we've expanded to Data 8 and in the future to Data 100, one of the things that have content team to be more engaged with the course is actually interacting with the professor themselves. We have Danilo coming from weekly meetings for Data 8 course staff have been very involved. Having a team in terms of the dev and the content curation and the upkeep of the tool actually be involved with seeing how this is given to students is really important. For Data 100, Dr. Grossman has also, come to our meetings, provided their input on how to align the tool, but then also the impact of how this open source work is actually being used by students.
Unsurprisingly, my answer is mentorship. But I do think that it takes so much people power, which is I think why we don't see it at bigger scale. But the students and new contributors that I see persist so often, a single common denominator is that they had a key relationship that helped them see themselves as an open source person. That helped them get at least one PR across the finish line and stuck with them through the messy middle where maybe they're going through code review or there's some CI/CD thing that they have to sort out, because that's the thing is so many of my students, when I was teaching semester classes, would get to the point that they did their PR and then they were cool, we're done now, right? And it's oh no, this is the fun part. This is where we do the this is where you have the professional dialogue over oh, you didn't actually read the instructions. That's pretty important. You need to format your stuff the way everybody else formats their stuff. You need to comment your code. All these professionalism pieces that make code work when we're all making it together. So I think having a key relationship that can help them through that part and see that that's not a failure. That's just that is the work. Help them celebrate it when they get across the finish line. And I would just add the sort of asterisk that I think it is most powerful if the mentor is actually somebody from the project community. I like to think I'm an interesting person, but to my students, it's, I'm their parent. They're not going to listen to me. But the minute that a developer that is on a project or works for a tech company comes and says something to them, it could be the same thing that I've been telling them for a full semester or a full 8-week mentorship program. It just lands completely differently. And I accept that. I see why it is that way. And I just want to help create more of those connections. So that's why I look for money to bring students to conferences. I invite people to Zoom drop in. I tell my students to build their network. And I don't think those things are always obvious to undergrads. So I think or grad students. So I think we need to really tell them to do it.
Can I go? Just to tag on that, Juanita Gomez, who's here, I met her at GitHub open source project. And I was this person's amazing and dynamic and exciting. So I invited her to my class at 200 people lecture hall. And she's here's my journey in open source. And here's how I got to contribute. And I got invited to conferences. And I got invited, now I'm in the room what happens kind of thing. And so for me, there's something about showing the students oh, this is a job pathway. It's a scientific pathway and it's a computer science career pathway, but it's also unfortunately, the students in my class, they're all thinking about jobs, but I feel super confident being if you join an open source project and you contribute and commit and you go to meetings where you're interacting with people, that's how it works. And how you get a job interview is somebody who knows somebody, those kind of things where you're I'm appealing to the students' desire to get a job, but I'm showing them this is whole socio ecosystem.
I would just add that people just recognize that people are coming at it from many different situations and positions. Like there are many people that are coming into the open source world as users, and they don't know that's a kind of contributing role or how you could, oh, let me help improve this documentation. Like that is a very valuable role in the community. They're not necessarily coding, right? Or they're not thinking about contributing in a traditional sense. And I think also look for the opportunity in our context. I've encountered, since we do research support and help people with research software, people that don't even recognize they are writing software that they wrote and they might be graduating and need to pass it on to somebody. Those are the opportunities when you can kind of convert them to some open source practices that make their software more sustainable, credible, all that kind of thing. But they would never think because they didn't take it in undergrad. They weren't a CS person, but they are actually developing software that could be an open source project that is valuable to their research communities. So it's kind of like, yeah, it's that mentoring part, but being there at the right time and recognizing the people might not conceive of themselves as actually doing this thing, right? Software development. But they're actually doing it, and we can, try to push them into an open source role. So yeah, that's what I would add.
Did I just add to Tim's point? I want to share something that I heard at Open Source Summit Japan. I heard this amazing talk from Ayumi Watanabe, who is really involved in OpenChain. And something she's shared stuck with me from studying new contributors was that she likes to frame it as coming to an event is your first contribution. And I thought that was like that rocked me. I thought that was like such a beautiful way to think about it, such a beautiful way to invite new people in. So I just tell everyone I know, I didn't come up with it, but I think that's just like a wonderful way to invite new people into the space that maybe don't think of themselves as open source people or software people, right?
All right. I'm not on this panel, but I do just want to build really, really quickly just on something that Eric said about students. I think it can often seem to students like contributing to open source is like just one more thing that they have to do, and it's the one they're not being graded on. And so it's the one that's going to fall. But that I like to tell students, I think that you'll get a lot more out of contributing to an open source project than you will out of an internship. Because the internship is this like very, very carefully curated experience that doesn't actually represent what it's like to do the work. And the open source contributions kind of do. And with that, who would like to ask our next question? Sam.
I'm kind of looking at YouTube, but anyone can go for it. You mentioned kind of offhand like that you have integrated the OA tutor into Canvas. I'm curious like how you all see different tools like the JupyterHub and the OA tutor meshing with these legacy systems we're forced to use on campus. I just Googled and found out that Canvas is open source. Maybe that's not correct, but yeah, I'm just curious about your experience doing that. Like what kind of like, I don't know, messiness there is.
Yeah, so I work a lot and look into open educational resources, and an ongoing challenge with OERs is interoperability and being able to connect these different open resources together. And it's an ongoing challenge. On one hand, there are advancements, and Canvas can serve as a hub where for different assignments, you can be using these different tools together. However, there's also many difficulties persisting with certain systems don't update, certain systems don't have compatibility with each other. So the best we can do is try to work with instructors and their need. So for example, recently we started working with Calbright College. They don't use Canvas, they use Brightspace. We had to bring in a new team member who's familiar with Brightspace to try to get OA Tutor operational with their learning management system, and that was a whole process. So it really comes in some ways with building on the instructor's needs, as well as identifying what we can improve on our own system. But it's, I don't have a concrete answer as to a solution because it's something in general that I don't think anyone does.
And just to kind of tack on that, when I was working with the Data Hub team at UC Berkeley, we had complete integration with Canvas. and it's a double-edged sword. It's Canvas, we're familiar with Canvas, but at the same time, we could do really cool things. And actually my successor in my position at UC Berkeley has done even more cool things, where if you're part of a course, there's an ID, and then there's a JupyterHub config for that ID with shared directories, memory limits, CPU limits. So you can really do some granular, assignment of resources on a student by student, group by group basis. And that is the one thing I miss in the Cal iCore project, is I don't have access to all those disparate, Canvas installations across all the different UC institutions, because IT is definitely not going to let me talk to their Canvas, full stop. So I do miss having that. It's clunky, it is what it is, but at the same time, it's incredibly useful on the technical, the invisible admin layer.
Yeah, lots to say on this topic. One thing that's funny that I will say as an anecdote is in distributing and disseminating Data 8. What does it take to get these community colleges to teach Data 8? This is a long horizon project. When we had the Canvas cartridge that any community college instructor could just download and upload in their local Canvas, that was a jump in adoption. That was huge for them. Right. And they're just oh, you have it already built in Canvas. That's increasing their probability and lowering their barrier to do something. I guess there's a lot of tools. And now we're also sort of talking about the ed tech space, right? So you're in Canvas, but then your JupyterHub's in a different tab, you're authenticated through Canvas, but you're not in the Canvas window. And then another tool, an AI tool, sorry to say, but the number of AI tools that might be in another tab is growing. And then you're all right, is the students are using the non-educational commercial tool, and then we're making layers that are skins of educational tools on top of them. I mean, there's also just this funny thing where I don't know, Data 8, maybe you use 8 to 10 ed tech tools. You're Ed Classroom, Pensive, Prairie Learn. There's just, how many tools can you make a single student in a single class? These are all really interesting. And some of them, Canvas, open source, but nobody deploys it outside of the Instructure servers, right? Prairie Learn is one that we're really into right now. It's lockdown browser. It turns out that it's very hard to deploy on your own server.
It is basically impossible to deploy.
Open source project, run very open sourcey GitHub stuff, but very, very difficult to ever run yourself. So there's a bunch of these things where you're they're open source, which is awesome. And culturally, they have an open ethos, but reproducible, you can launch it on some other thing, hard to do for some of the projects. But I think even that we're able to have this conversation, is the ed tech seem open, or does it seem vendor closed? The number of vendors that are want a student to pay $10 a month to, get some aspect of course things is quite difficult.
Thank you. And who's our next questioner? Is it Spot? Yeah.
So I'm a firm believer in the practitioner that you learn more from your mistakes than you do your successes. You've all succeeded very wildly as presented in front of us, but I'd like each of you to take a moment and talk about a mistake that you learned from in the process of getting to where you are today.
Ooh, spicy. Y'all nominating each other.
I don't know how many times I've taken down the JupyterHub accidentally or broken a user image for the students before a deadline. And I think the last one was I fixed something for Sacramento State's hub. And I'm oh, this will be great. It's 4 o'clock on Friday. Oh, it's President's Day weekend. I'm going to watch the Olympics. I'll just push this out to prod. And then Monday, there were about 150 students that couldn't do their work. And I'm watching bobsledding. And all of a sudden, my phone started dinging. And it was instructors saying like, hey, this is broken. We can't use R. What's happening? And I spent the next 2 hours unraveling what I did. And I was just like, crap, why did I do that? So yeah, it's, just living on the edge. Don't push to prod on Friday. That's that. That's mine.
I think kind of going off of that, we've had instances where we push a new change or we deploy in a classroom, something goes horribly wrong, and we have to rush to resolve it. And I think that's just a natural aspect of deploying technologies that are used by thousands of students when you have a team of around 10 to 20 members. You can only test so much. And I think we've come to understand that we acknowledge that it's impossible to fully replicate what an entire classroom looks like. So we take new steps and implement new measures to test as best as we can. Originally, we would have, for example, our content team just do a run of the content, and that was it. Nowadays, we work with instructors. We have someone from the staff check it. We check it, all these checks. And, sometimes mistakes will still slip through. But I think understanding that these mistakes are natural, they do happen, and instead building pipelines that allow you to build on them and reduce them as much as possible.
Yeah, so I think some of it, just the fragility of the different tools we use, like we were using Google Sheets and we had 15 people editing that, and then we got confused and didn't know what was what. We created you remember we created something called a sort order?
Yeah.
But then that wasn't a persistent identifier.
Mm-hmm.
So then we had, figuring all that out. And then like one good thing is like what fixes it, like what we said, okay, we need to automate all this. But then what I liked in other educational tools that build lessons is a solid CI/CD process and GitHub Actions that will do checks. So it's like, okay, once I screwed up a number of times, we're gonna copy this. We're gonna figure this out. So we have all those checks. I know when it breaks, and so we did do that. But we broke a lot before, and it lost, had a lot of confused content and referential kind of properties, and slowly figured it out. So yeah, it was fun.
I think the crucial line there was once you had screwed it up enough times, right? That's always the way it goes.
I'm part of a teaching community that actually says the era is the pedagogy.
Mm-hmm.
So I totally believe that.
Yeah, I screw up stuff all the time. So I'm trying to think of like a good example because I'm constantly like, oops, didn't mean to delete that repo. That's a Git flag that I've never seen before that I didn't mean to use. But I think, trying to stay a single answer that's maybe at a higher level is that when I started teaching open source, like everyone warned me, like, you're not going to know all the things, but I think it's like super uncomfortable coming from teaching other types of classes where like, the answer to the assignment, right? So I think when I started teaching and mentoring in open source, a mistake or a misconception is that I felt like I had to have all the answers for the students. And so I would like teach my class and then I would go home and like all night I would be like, I need to learn Rust tonight. All of it. I need to be like a Rust expert by the time I go to class tomorrow. Or like React. There was like a semester that we were using React and I was like, I don't even know what React is. This is when React was like newer. And I went home and I was like, oh, I got to show up and not look stupid. And I was like junior faculty at the time in a tenure track role. So I was freaking out. But I think, it's come full circle that now, at least with time, I'm able to see and hopefully model to my students that like the value isn't knowing all the stuff, because now more than ever, we see the field is changing so fast that you are never going to know all the stuff. So now I'm able to show up with confidence to be like, I don't know the answer to that. And like, of course I don't know the answer to that. But what I do know is like how we're going to find the answer to that. And like, here's how to craft a really good query. And here's how to like leverage our network to think. And here's how to do the outreach to find the right person to talk to. So yeah, I guess that would be my answer is I tried to know all this stuff and like you just can't, especially in open source. So lean into it. It's a mess. It's a fun mess.
Yeah, I got a similar story where my side quest that I tried to introduce that was like how to teach AI in notebooks. And I had a tutorial on March 10th in Washington, D.C. at the NAIR conference, and I had 45 people signed up. And I was like, yeah, no problem. And then, there was just a nest of things to debug. And I got on the flight with Sean, and we worked the entire flight on the way there debugging stuff. And then we stayed up till 2 a.m. debugging stuff. And like things just kept breaking and breaking. And you're like, many open source package problems, like they changed the name of LangChain. So that broke all my number. There's like tons and just thinking like, oh, LangChain RAG, I'll do like a simple explanation for like a freshman in college, like what LangChain is. But like, just every assumption that I had made about how easy it was going to be was just broken over and over and over again. I learned a ton, and like sometimes staying up late, like hacking on something is like where the gems come. But yeah, I thought it was going to be simple.
I think obviously like our tool goes down all the time as ourselves and things. We're having like a debug session yesterday. I think as a student in particular and taking today and developing content and being on both sides of the road gives perspectives. Some curating content for Chem, and I actually had a friend in that class. I think in the academic world, it's very easy to get tied up in like all the papers and the research and all the things that are technically backed and correct, like our BKT or learning algorithms and everything. But when talking to my friend, it was very, very clear that there were other hiccups in the tool, like notation things and small things that just derail the student experience. So I think as we've moved forward, we've incorporated more like course staff who have taken the course, instructors who are from the students, or student feedback week per week, just because it's like, and it's really hard to get that outside perspective if you're just on the developer side.
Thank you all. I think we have time for at least one more question. Thank you.
Hi. So I have a question for, I think Shane, Jupyter Notebook coursework. So is that available to anybody, who, like not a student registered to UC? So in other words, it's like a open courseware model?
Yes. So this is also kind of more of an Eric question, but I can answer this one. Yeah, the Data 8 notebooks are available online. The only thing you don't really get is like the lectures and, some of the answer keys, because if those were available, then all the students would get hundreds on their Data 8 courses, but maybe Eric can go a little deeper into that.
Yeah, everything's in public repos on GitHub. And if you want access to the private repo with the answers, you send us an email and we add you to a private repo.
Okay. Thank you.
All right.
And then I also had another question, and I didn't get your name. So you mentioned use of ChatGPT for questions, right? For EdTech. Is ChatGPT like available for students for free, or like, how is that?
Yeah, I think most of the chat and LLM usage that we front the billing and the costs. So a lot of the because we don't want, so we want the guardrails there first. The content is first generated, curated, and then checked over by us. The student, we've been testing how much we can push the LLMs onto the students, but at least for now, the students never interact directly with ChatGPT or LLMs. It's always through content, and obviously this flags a lot of questions that end up being incorrect or curated wrong.
Thank you for
Just to be clear, they showed a bunch of tools on different slides, and one of the tools was like how to make the review cards using like a combination of experts in ChatGPT. So it may have gotten confusing. It was like that one was sort of like an internal curriculum development tool, that had an API to ChatGPT, just to disambiguate.
Yeah, I was just curious why we're recommending one tool over another, that kind of thing as a, do we, yeah, it's a whole another question of like, sustainability and how the LLMs function and things like that. So how does academia view this?
Yeah, I will just say for my class last semester, there's all this like ed tech, like make a tutor bot, sign up for this, upload your course material, and then we would have your tutor bot. These approaches are much more like, let's build the infrastructure so that it's more like open source, and grant foundation funded. I did my class, like took the materials open source to make the RAG, to make the context, but then like how to deploy it. And I had like a public open ChatGPT, whatever they're called, a custom GPT for the class. And then you're back to that question, does everyone have access? But everyone has some free access, but sorry.
We're at time, so I'm going to say if you can put it in a tiny nutshell.
Yeah, just to clarify, there's a lot of projects out there that do develop chatbots and so forth. Our lab focuses mostly on studying how these tools can be used in the context of authoring or tutoring systems. It's not that we choose ChatGPT specifically, and we've done research that looks at how various LLMs hallucinate and how we can mitigate those hallucinations. But right now, at least in the lab, we focus mostly on content that may have originated from LLMs, but has been edited and reviewed by experts.
All right, let's have a round of applause for our panelists. Thank you very much.